What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at a new technique called completing the square, and this is going to be incredibly helpful for us moving forward with our quadratics. If we can factorize these ones, everything becomes much easier for our next few topics, especially when we start graphing some of these quadratics. So far, we've got really good techniques in order to factorize quadratics. We just look for two numbers that plus together to give the middle value and times together to give the last value. So if I've got something like x squared plus 8x plus 12, I can see really quickly that, 6 and 2 are going to work. 6 plus 2 gives me the 8, and 6 times 2 gives me the 12. This means that my answer really quickly is just x plus 6, x plus 2, full marks. But we need a technique if the numbers don't work that well. And what I mean by that is if we can't find a pair of numbers that add together to give the middle term and multiply together to give the last term, we're kind of out of luck. So for example, if I've got something like x squared plus 8x plus 6, we can't actually find something. It's really easy for students to go, 4 and 2, but we need to plus together to give 8 and times together to give 6. The only ways we can times together to give 6 are 2 and 3, or 1 and 6, and neither of those combinations can add together to give that 8. So we kind of need a new idea. So the goal for this is actually to try and create a perfect square almost out of nowhere using an incredibly silly trick. When I tell you, you're going to be like, this is stupid, but it's definitely going to help us out. Let me show you what I mean. So we're just going to start with a very silly example. I've got 4. I've got 4 of something. Who cares what it is? If I have 4 and then I plus 0 to it, well, I still have 4, obviously, right? I haven't actually changed the equation. I haven't done anything. I've added nothing. If I take this one step further, I could go 4 plus 3 minus 3, and you would agree that I still haven't done anything to this equation. I just had 4 things. I added 3, I took 3 away, but I've really just added nothing, or nothing has actually changed. So I'm going to use this idea of adding nothing to help make a perfect square. I've got x squared plus 8x, and the constant term that would make this a perfect square is plus 16. That would be 4 squared, which gives us the 16, and the 8 would be made by 4 times 2. So now I've plus 16, but that would actually change what I'm doing. So to add nothing, I need to minus 16 straight away. I'm going to put those in a different color so we can exactly see what's going on, but I'm going to then keep my other constant term of plus 6 on at the end. So now I've added and subtracted the same number. I haven't changed anything, but I've put these two things in. I'm going to treat the front half, this part I've put in red, as a perfect square, and I'm going to just factorize that straight away. This is going to be x plus 4 all squared. And then for the last two terms, I am going to simplify them. I've got minus 16 plus 6, so I'm left with minus 10. So now this is almost fully factorized. I've got x plus 4 all squared minus 10. That is using everything that I've plussed in and minused, and it's working quite well. But if we remember from a few lessons ago, this is actually also a difference of two squares. I've got a square value at the front. Instead of just x, it's x plus 4 all squared, with a minus, so definitely a difference. And then that last value is still a square number. Even though it doesn't look like it, I know that root 10 squared would be that 10 value. So to fully factorize this even further, I could go x plus 4 plus root 10, all in brackets, and x plus 4 minus root 10 in brackets as well. So my final fully factorized quadratic is x plus 4, that comes from that perfect square, plus or minus root 10, which has come from our difference of two squares. So this has used a lot of the ideas that we've been learning in the last couple of lessons, making a perfect square, then doing a difference of two squares. But if we can get it into one bracket, that's as simple as it's going to get. So we're going to do one more example with the steps at the same time. So I would highly recommend writing down the steps on one side of your page and doing the example alongside it. So our first big cheat is to make a perfect square out of nothing. What we're going to do is take the middle value, so the one with the x, we're going to half it and square it. That's going to tell us what to add and subtract. So if I've got x squared plus 10x plus 3, I'm going to half 10, which gives us 5, and then square that value to give us 25. This 25 is what I'm going to plus and minus. Again, I'm putting in a different color. You obviously don't have to, but these values are adding nothing, but I'm putting them in there to create a perfect square. Then our second step is to break this into two ideas. We've got the perfect square up the front and then just constant terms at the end. we're going to factorize the perfect square straight away. So I've got x plus 5 all squared. Then, because I've got minus 25 plus 3, I've got minus 22 at the end. Now I've got my first part of the difference of two squares and a value at the end, or a constant term. This last step of recognizing that it is a difference of two squares is something that students find very difficult. I've already done the factorization, I've done the work, why do I have to do it again? But this is more factorized. If we can put it in one bracket, that's awesome. So here I've got x plus 5 squared minus 22. I can see that that's going to be x plus 5 plus root 22 and x plus 5 minus root 22. So my final answer is x plus 5 plus or minus root 22. The big pro tip for this is once you've found the first perfect square, just throw that down with a plus or minus of the last number under a root. X plus 5 plus or minus root 22 is full marks. So there is one more case that we need to learn, and that's when there's not a difference of two squares at the end. Obviously for a difference we need a minus or a difference, but sometimes that doesn't happen. We have a plus in between our two things. So here if I've got x squared plus 6x plus 18, I've got to half the 6 and then square that value. So I'm adding 9 and taking 9 away. Now I've got x squared plus 6x plus 9, that's my perfect square, minus 9 plus 18. When I do that factorization of the perfect square, I've got x plus 3 all squared, and when I simplify that last term, I've got plus 9. This is now different to what we had before. We've always had a minus in between, but this time it's a plus. This is actually way less work for you because we're done. There's no further factorization that we can do. This is our final answer. X plus 3 squared plus 9, happy days. So the big summary for this lesson, because there is quite a lot of information, the number one thing we're trying to do straight away is create a perfect square by being a little bit sneaky. Plus or minus that square value, you're not changing the value, you're not changing the equation, but we are making a perfect square almost out of nothing. Then we have to factorize the front half just using our perfect square and simplify the back half. Hopefully this will give us a negative for a difference of two squares, but it might not. And then finally, if it does give us that difference of two squares, what I need you to do is put whatever's in the bracket, our perfect square, x plus, x minus, whatever, then plus or minus the root of the second value. This will be fully simplified in this condition. This is definitely a topic that we need to look at a few different times. Just getting into the rhythm of plussing and minusing things does take a little bit of time, but I guarantee once you start doing it, you will find these questions pretty easy. The next lesson is going to look at how does it change if it's an odd number in the middle. The maths is exactly the same, but our working out can get a little bit messy. So that's why I've made it into 2 videos, but I think you're going to absolutely smash that one as well. Thanks so much for watching this lesson, and I'll see you later.